machine learning, and an aspect of machine learning that is I think will soon become an issue. Well, actually, you have seen um, most likely that there has been tremendous success with machine learning and deep learning, which has become very popular, and people like it, and they have great results, and so whenever something works well, people want, everybody else wants more from it, and there's a lot of pressure for it, and from this, and we can see that the kind of problem they're able to solve is as a number of characteristics that are well associated with usually single objects, and basically are not able to take account the connection between several things. And well, if you look at what Facebook or LinkedIn or a number of other large projects are doing, they have proved that there is a very important value in the connection between things, and it would be great to have machine learning being able to be applied to these problems, but as it is with the way that machine learning is done currently, it's it's built over feature vectors that describes objects, and the objects are like individual objects. So basically, the way it works, if a few of you are not don't know much about machine learning, supervised learning, I would say. I didn't write, I'm sorry. So they have samples that describe objects and describe what is interesting about this object, and by feeding a large number of such objects with their description, they build a statistical model that can be used to do prediction or classification about what the objects are. So afterwards, you present an unknown object, and the model is normally supposed to guess what the object is, and in this way make a decision that is based on this knowledge of it. The main disadvantage of this method is that the description of the object, it must be thought of beforehand, and it's not this aspect of the process is the one that is not flexible. So it's applied to a single object, and what is missing is that it's the valuable part in the mass of data, which is about the connection between things. It's not there. So the samples describe object, but not the connections between objects. Now, the connection, we have seen that, like from Facebook and later project, we have seen that the connection is actually very valuable, and there's much more data in the collection, in the connection, sorry, than the description of the object themselves. And so in order to be able to extract information from the connection, it's actually necessary to build samples that include the connection information. And because there's so much more connection than objects in databases that keep both kind of information, an exhaustive generation of possible connection is just too much work. It becomes way too big very quickly, and the only way to go around is to have a search process that will look at the possible connection of interest within the given database, and then identify the information of interest that might be useful to produce samples that can then be used for machine learning. So the interest of having graph databases is that it naturally represent connection between objects, and so it makes the process of building samples out of connection information, say, possible. So the connection is represented directly, and it's easy to search a graph to find objects that are directly connected or closely connected to find some pattern that might be of interest. Now, there's many kind of databases, from early connected data project. Everybody tried to use SQL, and basically they ran into very big problems because the SQL was built and optimized for data that are independent records that are independent from one another, and connected data is a kind of problem that is just too difficult for SQL. And there's additional problems like SQL queries require an exact knowledge of the structure of the database, and as such, it's you need to program queries, and you need an expertise of what is in the database in order to extract potentially learnable patterns. With graph database, your information is represented as node and connections between nodes, and as such, it's possible to search for things like any kind of connection between, say, two persons or a person in a given place, and you will not only get a result that says whether the two are connected or not, but you will also be able to get an answer as to what kind of connection exists. And from this information, it's possible to build a feature vector that will potentially be useful for machine learning. And as such, you will be able to have a predictive model or anomaly detection for objects that are connected and not only single objects by themselves. It can be very important for cases like fraud detection, for example, where people who know the methods that are tested for individual things, they will spread their action into many small parts, where each part is looks okay, but if you look at the bigger picture, you see that all together the many actions are actually a fraud. So you have the same thing like with there are rules here against money laundering. Well, so when you go to the bank and you deposit like I think $10,000 cash, you get the bank is forced to report to the government that you deposit that. But if you have 10 small deposit of 1,000 here and 1,000 there, then it will go under the radar and it will work. So you actually need to find patterns in order to identify the problematic situations. So. It's already finishing. So actually, I think that the connection between objects is important. It hides very valuable information, and as such, for this reason, I think that the combination between search within the graph database and machine learning will be more and more in use in the future. So.
So do you have questions? We have a lot of time for questions. So, as you said, the problem with classical machine learning is fixed vectors, whereas in a graph database, you don't have a fixed number of connections, of connection types, and so on. So how do you encode in a vector, or did you relax the fixed vector issue?
Well, if you have an encoding about an operation between two persons, you can have the feature vector can contain a few parameters from one party, a few from the second one, and some description. But the thing is that you will use a search component to decide which parties are make sense to build an actual sample.
So, am I hearing that you're using the edges instead of the nodes? Sorry.
Yeah, edges are connections. Edges are connections.
Of course, of course. So the edges are what you're using in the as to feed the machine learning algorithm.
Well, sort of. You use the edges so that you're able to have a single sample that contains information from related objects and not only from a single object without connections. Now, the description of the connection you have, this one is has to be fixed because machine learning techniques need a fixed feature vector, but the identity of the object and the connection between them, this is something that you can search in the database.
Do you have examples of encoded vectors?
Well, what can I say?
In order to continue his question, I would like to have a visual example of connected data, connected object in the data. Because you said that we cannot, SQL is not good for this kind of data because the items is not independent. Okay, so in order to make a big image in my mind in terms of the dependency of the object in the data, is that possible for you to give us an example?
Okay, well, I should have had something like this in the presentation, but I was a bit short of time because I just came to Montreal a few days ago, and I was like too tired from the travel. But think about if you ever used a whiteboard and you try to draw something about some object with circle and one thing connected to another and connected to another. Well, it's exactly a graph.
Think of your Facebook friend graph. It's not then.
Just make an example. You gave us an example about the fraud detection. So this is the data of the
Okay. So for fraud, you will have people, you will have a bank account, you will have a transaction.
Yes.
These are all objects.
So why we cannot put them in a relational database?
You can. The issue is that you will have to search for it. And searching in the relational database is much harder for a number of reasons. One is that the data is encoded into a table, and so you have to know the structure in order to query the data.
Yeah.
In graph databases, you can have you start from a given node, and then you can ask questions like what kind of connection are there and what is connected to it. So
it's kind of an unstructured database.
Yeah, it makes it easy to encode unstructured data, and it brings the natural structure of the data. So you know what are the connection between the type of connection between the objects that are of interest.
Thank you for opening this door in my mind because I have to go and do more research again. So thank you so much.
Okay.
Can I think of your friend cloud? If you have a friend column, a person table, and a link table, it's easy to traverse the links from you to your friends. But when you go to friends of friends, SQL is bad at recursion. There are recursive queries in SQL, but they're unwieldy. So in graph database, you can say, I want people related by the friendship tab up to 2 links down or n links down. And that's a natural query in a path language. So this is what graph databases are about. And this is why it's, I'm still really curious about the shape. The shape is irregular, like the number of friends that one person has is not constant. I may have 2 friends, you may have 10. So when you make these vectors from the person, if you do it from the edge, I see it. But if you do it from the person, like they won't have the same number of features.
Well, you need to make vectors out of a constant number of friends. But the thing is that the vector will represent something that connects different objects.
So again, it's the
But you do need a constant format for the feature vector.
Yeah, I guess for your question, sorry, you can easily put a feature as a friend, for example. Then, for example, Alex is a friend of Bob, so you can easily put there.
That's what I said. That's
And
what
then join on them. That's the complexity. Like join of like friend of 10 distant on a data relational database is like join is the worst complexity. So that's why graphs are better. But, yeah, but I don't want to like let's discuss later. But my question from you is, so we have connections and we have features in graph databases for each node. Is it correct?
Yeah.
Okay, so and we don't have I don't know any machine learning model that can work with different number of features for each user. So how do we model it? That's the main question that comes to mind. Like how do I fit database? Because the point of graph database is not to store many nodes, so you don't create all the columns for every user.
No, but if you have an information like you have you're a friend with one other person, you store this as a direct link between an object in the database that represent you and an object that represent your friend, and the link between the two.
And again, I have to go back to relational databases to be able to fit it to the model, or I can create a graph database to the model. That's my question. Should I go back, create a relational database for it, or I can create a graph database to the model?
Well, the graph database is the representation of the is a complete representation of the data, and it allows searching, an easy search in it, and from it it's possible to extract information about connected objects that are of interest.
So via searching, we get information to, for example, predict the behavior of some spam.
Well, if you have, if you ask question about a friend of you that live in some specific city outside of Montreal and would have other activities, then using a graph database, you have a direct connection between you and each of your friends, and the given friend will have a direct connection to the place they live in. So the query to get to the information of interest is very localized and depend only on the number of friends that you have, basically.
Okay, so you mean I can search on graph database to extract more information to feed my model and other network.
Yeah, you extract the information using a small search, and you use the extracted information to build a sample for the machine learning.
So actually, just follow on that. So do we have a machine learning library that can connect directly to a graph database? You don't have to do that search part?
Not that I know of. I would think that it's very domain dependent, because the connection of interest will depends on the field that you're dealing with. So
Maybe last question, and then we'll have the networking afterwards.
So you've started to play with that. Are there particularly good queries to make of the graph database to get good results with the machine learning? Like, you observe patterns, like for example, number of connections of certain types or number of connection to a certain type, things like that. What are the very useful features that
Well, I'm much more on the graph database than machine learning for now. So I'm not specifically working on the combination of the two yet, but it might be very close. But I also I've seen enough machine learning to feel where the weakness of this kind of system is, and I believe that the graph databases and the search within the connection database will be very useful to learn patterns of interest.
Okay, thanks very much, François.
Well, welcome.